Hi everyone, I would like to thank the organizing committee for allowing me to show you the team's work on the development and validation of a real-time RT-PCR for the diagnosis of foot-and-mouth disease. A brief summary of FMD. This disease affects only animals with cloven hooves and not humans. Its occurrence in the livestock and its spread cause high economic losses. Endemic in different regions of the world, FMD is characterized by the appearance of a vesicle in the mouth and hooves. FMD is rarely fatal in adults, but also 100% of morbidity, and this is the first disease for which the OIE established official statute recognition. The causative agent is an aftovirus of the Picornaviridae family, including 7 genetically and immunologically distinct serotypes. This small enveloped virus of about 8 kb initially infects the epithelial cells of the soft palate and pharynx. Different diagnostic methods have been developed over the years with varying speed and sensitivity. The lateral flow device, a rapid chromatographic strip test based on a monoclonal antibody. The integrate ELISA capture of viral antigens, or viral isolation of FMDV susceptible cells with the appearance of cytopathic effects. All three tests require the handling of live virus and therefore the use of an adequate safety laboratory. The first test to use is the real-time RT-PCR assay, which can be used in a lower security laboratory after release of the viral particles and therefore not infectious. As a small aside, our team has developed a system for the inactivation of infectious viral particles present on EAVLD, and this presentation is given by Aurore Romer. To our knowledge, in the literature, a multiplex real-time RT-PCR study for at least 3 targets for FMD are designed for the simultaneous detection of different viruses or specific topotypes or lineage, as Suela Benfried will be able to present to you in the poster session for the detection of FMDV Africa G4. In our laboratory, we are currently using a duplex to search the 3D and ROCs genes, and it is therefore interesting to develop a pan-FMDV triplex in order to improve the diagnosis of FMD, especially to the risk of genetic mutation. This triplex was designed to detect the two most conserved interstrain genes 2B and 3D, with a high percentage of invariant nucleotides at 61% and 58% respectively. The controlling endogen is GAPDH. This is a one-step and pandemic FMD RT-PCR. Its development and validation were carried out with two parallel nucleic acid extraction methods with silica colon and magnetic bead, and by following the French standard and the OIE manuals. The OIE was summarized the validation pathway, and this is what I will present to you today, and you can follow the progress of the step on each slideshow. The first steps are to access the analytical characteristics. The test is designed to be selective with an analytical specificity that does not detect other strains. Similarly, out of 53 strains representing the 7 serotypes of FMDV, and all were detective positive for both viral targets. The detection limit of the PCR is excessive using dilutions of synthetic RNA developed for both viral targets, and is estimated to be 10 copies of RNA per 5 microliters of RNA added to the matrix. The detection limits of the method is evaluated with two hour extraction methods in parallel. FMDV3 epithelium and nasal swabs were spec'd with our synthetic RNA. The detection limits are evaluated at 100 copies of RNA for epithelium and 1000 copies for nasal swab. The repeatability is estimated by evaluating variation in results of 3 replicates with 5 samples in 2 sessions. The extra session coefficient of variations of our extraction method is estimated to be about 3% of silica colons and about 1% of magnetic beads. The reproducibility is a measure of the agreement between results obtained in the repeatabilities. Similarly, the intersession coefficient of variations of the repeaters are about 5% and 6% respectively. The next step is to characterize the diagnostic parameters of our matrices. Estimating diagnostic specificities and sensitivities are the proportion of known negative samples to be undetected and the proportion of known positive samples to be detected, respectively. As can be seen with our triplex, we found the wide status of the tested samples per matrix. The strength of the triplex is that even if there are mutations in one of the 2B or 3D targets, if other targets is detected then the sample will be considered FMDV genome positive. If the sample is considered positive, it will be confirmed or not by a second technique. The third step is interlaboratory reproducibility. In the framework of the annual proficiency test, 10 volunteers laboratories participated in the validation of the method. For this purpose, 16 blind samples were sent to them. The extraction methods are free, but as shown in the OIE manual, the protocol, regions, and controls must to be identical and mandated. Thus, a ready-to-use master mix was mandated, as well as the thermocycle program. The laboratories had to be able to determine the status of the samples. The samples were divided into different levels of infectivity with bovine crushed epithelium, FMDV3 type OA, SAT1, SAT2, and SAT3. Homogeneity panels consisting of 10 samples per level were associated before shipping. The acceptance criteria were validated and the samples were considered homogeneous. Participants were given 4 weeks to return the results. Once all results were received, a stability panel was tested, which was produced kept together with the homogeneity panels. The acceptance criteria were validated and the results could be analyzed. If sample statuses are validated, then raw CT values are analyzed for all infectivity levels combined with means per target, standard deviations, intra and inter-laboratory coefficients of variation. In total, 8 extraction methods were used, including 6 automatic, 3 manual. The same kit was used with both forms, 3 silica colon, and 5 magnetic beads. With the same kits, test volumes range from 100 to 451 microliter. Similarly, elution volumes vary between 40 and 100 microliter. And finally, this is 5 different thermal cycles were used. Our lab found the correct status of samples without inter-sample cross-contamination. The means per target across all levels are presented in this table, in comparison with the CT values obtained with our homogeneity panel, and they are similar. Also, the standard deviations are calculated and they are rather homogeneous between the three targets. Similarly, the interlab coefficient of variation for each target is reported with less variation for GAPDH than the two vowel targets. Finally, the percentage of incidentally corresponds to twice coefficient of variations, less than 20% for the three targets. However, the French standard and the OIE manuals do not indicate criteria for the validation of this state. Based on other records of the same types, the criteria used are less than 2 standard deviations for the worst CT values obtained, which is the case. For the interlab coefficient of variation, they must be less than 20%, and this is the case too. If you would like more details on our activities, I invite you to see our website you can find here. I would like to thank all the participants in this development, and I would like to thank my team for the work they have done. And of course, thank you to you for your invitation.